Welcome, my dear students, to Standard 10th Class Science and Technology Part 1. We begin with the 8th lesson, Metallurgy. In this lesson, we will cover physical properties of metals, physical properties of non-metals, chemical properties of metals, reactivity series of metals, chemical properties of non-metals, ionic compounds, metallurgy, and its various concepts. Reaction of metals with oxygen. Metals combine with oxygen on heating in air and metal oxides are formed. Sodium and potassium are very reactive metals. Sodium metal combines with oxygen in the air even at room temperature and forms sodium oxide. You look at the reaction over there. Sodium plus oxygen giving you sodium oxide. Since it is the most reactive metal, on exposure to air, sodium reacts with oxygen in the air and readily catches fire. Therefore, to prevent accident in the laboratory or elsewhere, it is kept under kerosene. Oxides of some metals are soluble in water. They react with water to form alkali. That is, alkalis are the bases which dissolves in water. Look at the reaction over there. Sodium oxide, which is formed as a result of the combination of oxygen and sodium, when reacted with water, gives sodium hydroxide, which is an alkali. We know that magnesium oxide is formed on burning magnesium ribbon in the air. Magnesium ribbon, when it is burned, it forms magnesium oxide, and when magnesium oxide reacts with water, it forms an alkali known as magnesium hydroxide. Please look at the reaction over there, my dear children. Magnesium plus oxygen giving you magnesium oxide. That is, when magnesium ribbon is burnt in the air, it forms the white powder of magnesium oxide, and when this white powder reacts with water, gives you magnesium hydroxide, which is an alkali. Reaction of metals with water. Highly reactive metals like sodium and potassium react rapidly and vigorously with water and liberates hydrogen gas. The reaction states that first reaction, sodium plus water giving you sodium hydroxide plus hydrogen gas is liberated and heat is liberated as well. Potassium, when reacted with water, gives you potassium hydroxide and hydrogen gas is liberated plus heat is given out. On the other hand, calcium, which is less reactive, reacts with water slowly and less vigorously. The hydrogen gas released in this reaction collects on the surface of the metal in the form of bubbles and the metal floats on water. The reaction follows calcium plus water giving you calcium hydroxide in the aqueous state plus hydrogen gas is liberated. The metals like aluminium, iron and zinc do not react with cold or hot water since they are less reactive, but they react with steam to form their oxides. Hydrogen gas is released in this reaction. The reactions are as follows: aluminium plus water giving you aluminium oxide plus hydrogen gas is liberated. Next reaction, iron plus water gives iron oxide plus hydrogen gas liberates. Zinc plus water giving you zinc oxide plus hydrogen gas liberated. Reaction of metals with hydrochloric acid. When samples of aluminium, magnesium, iron or zinc are treated with dilute hydrochloric acid or sulfuric acid, sulfate or chloride salts of metals are formed. hydrogen gas is liberated in this reaction. The reactivity of the metals can be indicated as magnesium is more reactive than aluminium, aluminium is more reactive than zinc, and zinc is more reactive than iron. Look at the reactions over there, my dear children. Magnesium, when reacted with hydrochloric acid, gives magnesium chloride and hydrogen gas is liberated. Aluminium, when reacted with hydrochloric acid, gives aluminium chloride plus hydrogen gas liberation. Iron, when reacted with hydrochloric acid, gives iron chloride plus hydrogen. Zinc plus hydrochloric acid giving you zinc chloride plus hydrogen gas is liberated. That means the conclusion of this is when metals react with acids, the chlorides, the respective chlorides are formed and hydrogen gas is liberated. Reaction of metals with nitric acid, that is HNO3. Nitrate salts of metals are formed on reaction with metals with nitric acid HNO3. Various oxides of nitrogen, that is nitrous oxide, nitric oxide, nitrogen dioxide, are also formed in accordance with the concentration of nitric acid, that is HNO3. The first reaction over there, my dear children, copper when reacted with concentrated nitric acid, that is HNO3, gives copper nitrate plus nitrogen dioxide plus water. Next reaction, copper when reacted with dilute nitric acid gives copper nitrate plus nitric oxide plus water is formed. Aqua regia. Aqua regia is a highly corrosive and fuming liquid. It is one of the few reagents which dissolve the noble metals like gold and platinum. Aqua regia is freshly prepared by mixing concentrated hydrochloric acid, that is HCl, and concentrated nitric acid, that is HNO3, in the ratio 3:1. Reactivity series of metals. Scientists have developed the reactivity series by doing many experiments of displacement reaction. The arrangement of the metals in the increasing or decreasing order of reactivity is called as reactivity series of metals. Metals are divided into groups according to their reactivity. First group, highly reactive metals, that is potassium, sodium, lithium and calcium. Second group, that is moderately reactive metals, magnesium, aluminium, zinc, iron, tin and lead. Last one, that is the less reactive metals, copper, mercury, silver, and the lowest is gold. Reaction of metals with non-metals. Noble gases like helium, neon, argon do not take part in the chemical reactions. So far, we have seen from the reactions of metals that cations are formed by oxidation of metals. If we look into the electronic configuration of some metals and non-metals, it will be seen that the driving force behind a reaction is to attain the electronic configuration of the nearest noble gas with complete octet. Metals do this by losing electrons, while non-metals do this by gaining electrons. The outermost shell of noble gases being complete, they are chemically inert, that is inactive. You have seen that ionic compounds like sodium chloride is formed as sodium metal gives away one electron while the non-metal chlorine takes up one electron to complete their octet. Look at the diagram over there, my dear children. Sodium plus chlorine, that is sodium metal, when reacted with the non-metal chlorine, giving you sodium chloride, which is an ionic compound salt is formed. Similarly, magnesium and potassium form ionic compounds like magnesium chloride and potassium chloride respectively. Chemical properties of nonmetals. Nonmetals are a collection of elements having less similarity in physical and chemical properties. Nonmetals are also called as electronegative elements as they form negatively charged ions by accepting electrons to complete their octet. Reaction of nonmetals with oxygen. Carbon with reacts when reacted with oxygen gives carbon dioxide, which is highly acidic. Next, carbon reacts with oxygen at partial combustion to form carbon monoxide, which is neutral. Sulfur, when reacted with oxygen, being a non-metal, with complete combustion, it gives acidic sulfur dioxide. Generally, non-metals combine with oxygen to form acidic oxides. In some cases, neutral oxides are formed. For example, carbon plus oxygen giving you carbon monoxide with a partial combustion. Reaction of non-metals with water. Generally, non-metals do not react with water except halogens. For example, chlorine on dissolving in water gives the following reaction. Chlorine plus water giving you hypochlorous acid, that is HOCl plus HCl. Reaction of dilute acids with nonmetals. Generally, nonmetals do not react with dilute acids. Halogens are exception of this. For example, chlorine reacts with dilute hydrochloric acid as follows: chlorine plus hydrogen bromide giving you hydrochloric acid plus aqueous bromine is formed. Reaction of nonmetals with hydrogen. Nonmetals react with hydrogen under certain condition such as proper temperature, pressure, and a catalyst is being used. Sulfur, when reacted with hydrogen gas, giving you H2S gas. Nitrogen, when reacted with hydrogen, gives you NH3, which is ammonia. Ionic compounds. The compounds formed from two units, namely cation and anion, are called as ionic compounds. The cation and anion being oppositely charged, there is an electrostatic force of attraction between them. You know that this force of attraction between cation and anion is called as the ionic bond. The number of cations and anions in a compound and the magnitude of the electric charge on them is such that the positive and negative charges balance each other, as a result of which ionic compound is electrically neutral. Ionic compounds are crystalline in nature. The surfaces of all the particles of the crystalline surface have a definite shape and are smooth and shiny. The regular arrangement of ions in the ionic compounds is responsible for their crystalline nature. The arrangement of ions is different in different ionic compounds, and therefore the shape of their crystals are different. The main factor that determines the general arrangement of the ions is a crystal in the attractive force between oppositely charged ions and the repulsive force between the charged ions. Because of this, the general crystalline structure has negative ions arranged around a positively charged ions and positive ions arranged around negative ions. The two important factors responsible for the certain crystalline structure are size of the positively and negatively charged ions, magnitude of the electric charge of ions. The electrostatic force in the neighboring ions with opposite charges is very strong. That is why the melting point of ionic compounds are high. Also, the ionic compounds are hard and brittle. General properties of ionic compounds. First point, the attractive force between the positively and negatively charged ions is strong. Therefore, the ionic compounds exist in solid state and are hard. Second point, the ionic compounds are brittle and can be broken into pieces by applying pressure. The intermolecular forces of attraction between them is higher in ionic compounds since they are solid, and large energy is required to overcome it. Therefore, the melting and boiling points of ionic compounds are high. Ionic compounds are water soluble. This is because water molecules orient in a particular manner around the ions separated by dissociation process. As a result of this, a new force of attraction is established between the ion and the surrounding water molecules, replacing the original intermolecular attraction. An aqueous solution of ionic compounds are formed. Ionic compounds are, however, insoluble in solvents like kerosene and petrol. This is because, unlike water, a new attractive force cannot be established in these solvents. Fifth point, the ionic compounds cannot conduct electricity when in a solid state. In this state, the ions cannot leave their places because of their intermolecular attraction. However, in the fused or the molten state, they can conduct electricity, as in this state, the ions are mobile, that means moving from one place to the other. The aqueous solution of ionic compounds conduct electricity as they contain the dissociated ions. On passing current through the solution, the ions move to the oppositely charged electrodes. Due to the electrical conductivity in fused and dissolved state, the ionic compounds are called as electrolytes. Thank you, my dear children.